All right, thank you guys and gals out there for joining me for the second presentation on tank heating design. Last week we covered a lot of the tank types, some application examples, some different products. Somebody's got some feedback there. Let me get that taken off. And this time around we're going to cover, resources, calculators, tools, some strategies and sales tips, budgeting. I'm going to maybe show you some quick examples of budgeting and how you can use that as well. Everybody's got a little bit of a feedback out there. All right, good enough. With that, we'll get started. Now, last week I mentioned before, hopefully you have it, hopefully you've seen it. If you don't have the PX131, download it. I'd send it with your tank heater quotes. It's just a good illustration of the options available to you. I travel with one because it's just nice to kind of give an overview breadth of what we have to the customer. With that said, we're going to dig into some of the details so you understand what goes into that, some of the calculations and designs. So when you're doing the calculation or you're able to walk through an application with a customer, you're helping your credibility, right? You're bringing value to that customer to be able to sit down and discuss, the tank type they have, or the application, fill rates, what specifically the heating, what do you recommend, materials. And it's all illustrated in a lot of our literature if you just know how to pull it out and know maybe how it correlates to the real world calculations. And so everything has, meaning. It's just good to review it and go and show you what the impacts are of those meanings. I'm going to talk in more like just technical terms for a couple of slides here just to get the background basis, and then we're going to go through the calculators. But it's always good to know where the numbers come from, what they mean. In the case of of heating applications, you've seen Q total many times in my presentations, in our catalog, and in our different products. It really is just a summation of how much thermal input do we need to either maintain temperature, raise the temperature. You can even and then calculate it for the loss, correct, to make up for that. And those together, depending on the application, it's all one basic formula, and just knowing how to apply it, where to apply it, and also how to interpret and interpolate your results to give the best option. This gives you the competitive advantage. If you just do straight pen and paper based on calculations, a lot of times you miss the real world opportunity to sell a better solution to your customer, provide more options to the customer, and really, provide your value to the customer in selling them, and hopefully be their thermal advisor going forward. A couple key terms. Specific heat is going to be specific to everything, whether it's the specific heat of the material you're heating, to the metal, the tank itself, the fluid. Heat of fusion is simply, again, you may notice they're all BTUs, and that correlates into kW. Heat of fusion would be the input required when you're heating a solid to a liquid, when you're melting something down. That's the heat of fusion. You often think of that as the melting input. So there's heat of vaporization. If you're doing a boiling application or a vaporization application, that's the heat of vaporization. And then the density, which is the mass you're heating, the molecules. The amount of molecules plus the specific heat of the molecules, and then your delta T is going to essentially be your equation, which is pretty straightforward. And then after that, we have to worry about our losses. That's maintaining the tank. Sometimes you're not worried about heating a product at all. You're just worried about offsetting their losses. And in doing so, that may be all the thermal input you need. But you have to be careful, because there may be a situation that arises, or something in the foreseeable future where they need some thermal input. They need the ability to heat up in the case of a shutdown, maybe in the case of a startup. And you want to walk through that with the customer. Hey, have you considered this? And those factors are the thermal conductivity and the thermal resistivity. That is K and R. Now, K is commonly referred to as U as well, and we'll talk about that in details, but we don't need to waste a whole lot of time on that because we have calculators for that. So think of, heat up and heat loss in the case of tank heating. And, they all follow the rules of thermodynamics. We're mostly focusing on the first rule, which is the summation of zero. You're losing heat to the environment, or you're trying to heat something up, so you're trying to get the equation to equal out. And as we go through, it's important to remember that the measure of specific heat is based off of water, and that is, one thermal BTU per pound per degree F temperature rise is water, and then everything else is kind of interpolated off of that for your different components. That said, we'll skip to the next. So when the equation goes through, I got to find out who's flipping through their pages. Give me a second. There they are. Turn them off. Okay, so back to the simple equation. We're not going to focus on this too much, but that's the basis of all this. It's the temperature change not only of the fluid, but of the tank or the whatever your container is. Phase change we're not going to worry about too much because this isn't a process application as much as we're just simply talking tank heating. You could have phase change. We're going to talk about that more in boilers and heat transfer systems and vaporizers next month. And then losses. So losses to your environment. That's through your tank. Through your tank. That's through the supports. That's through heat sinks and connections. And all that just comes out into essentially the heater you require. What is the thermal input? What do I need the heater to do, and how to apply that? All your ratings are done in BTUs. Obviously, the conversion for that is 3.412 BTUs per watts. Or in most cases, when we're calculating kW, you're dividing by 3412, and that's pretty common throughout everything we do. What I would point out, though, in thermal input, the kilowatt ratings in all of our products and catalogs are based off kilowatt hours. That is the thermal input over an hour. So the heat up time becomes a topic of discussion, and you should have that discussion with all your customers. How long do you have to do this? And we have some calculators and how to understand the calculators I'm going to review a little bit. But always remember it's kilowatt hours. And the rating is the H gets left off. It's left off in pretty much all of our catalog products. But that is the thermal input in an hour. And doing so, when you have heat up times, maybe you have longer to heat something up, less time to heat something up, that all becomes a factor, and it's just important to remember. Loss. Back to just showing you where the numbers are in the calculations. Heat loss would be lost through the tank wall, through the insulation. It's lost to the environment. I mentioned before, K and U are interchangeable. Basically, think of R as the resistance of heat to pass through it. So insulation, the R factor, right? The larger the R factor, the better insulation. Inverse of that actually is, so that would mean the lower the U or the lower the K, the higher the insulation value is, the better insulation. And you'll be given the R factor in most installations. You can look them up in charts and graphs. The equation for that is quite simple. You take the K factor, or you can back calculate for the R factor. There's a constant converting BTUs to watts, again, per hour. And that's the Y in the top right. The equation is in the back of the catalog. It's just kind of buried there in the subnotes. And so you can always calculate your K or R or U if you need be. But most of the time, it's generally given. But that is over the surface area. Loss, to the tank wall, to the base of the tank. Calculation is there. It's, but we've got calculators and things that we're going to review, and that's what we really want to get to. So let's start simple. Engineering data sheets. The traditional old school way of us designing any application or any heater that we provide. Back in the years and years ago, before the internet and email and all the quick tools and calculators, they actually used to give out books of these that are in our catalog, and the customer would fill that out, or you'd sit down with your customer and fill it out. Basic information. None of that information's changed, though. It goes into the calculators and the things we'll review here in a minute. But that stuff just hasn't changed. It's still the same calculation using the same graphs and charts, and we'll run through those really, really quick. They're good to have. I download them off, our website. If a customer doesn't truly know what they want, maybe they need a little bit clarification in their application, I walk them through this. It's a good way for you, interfacing with the customer, also to review what they need. So it's just good to have. Now, calculating heat loss, something I want to point out to everyone on the call. There's actually two specific things I want to talk about with heat loss. So, you've got insulation factors. You can do your heat loss based on the thickness of insulation, but a lot of times we get the request for no insulation on a tank. That happens all the time. So for temperatures, as your tank is, depending on what you're heating, so you're heating oil, 350, right? Much higher temperature. Well, there's a radiant effect, right? It's significant. The temperature between the environment and the tank is significant, so your losses are very great. And it's kind of exponential. You can see that in any of the graphs. But for lower than 250 degrees, usually freeze protection, smaller applications, this quick calculation of 0.6 times your surface area times delta T is amazingly accurate and pretty much the best estimator you can use for a quick calculation of what your heat loss is. Wanted to point out it was there. We use it all the time. But more importantly, in heat loss, when you're doing for higher temperature tank heating applications, I mentioned before the gradient is exponential. So, as you get, significantly hotter, there's a radiant effect. You're losing more to the environment without insulation. So you'll notice in all of our calculations, and in our calculator that you either have or will have at the end of the presentation, they divide the factor by 2. And why would they do that? Well, when you're heating something in a heat up application, there's a start temperature and an end temperature. In a maintain application, there's not. You're maintaining a temperature, so that loss is constant. You're at the high temperature already because you're not raising the temperature. So it's important to differentiate between the two if we're maintaining or heating a product. If you're heating a product, you got a start temperature, so your heat loss is X, but at your end temperature, when you finally heat the tank, it's at Y. The difference between those two is essentially what you want to use as your heat loss, because it can be extreme. And you want to maintain your losses between the two to know how much thermal input. This is there to keep you from oversizing your heater. I mean, you can size it for the worst case scenario. You absolutely can. But if it's a higher kW requirement application, you can find where you'll oversize your heater by a significant amount. And it's just important to know that calculation and that they're dividing that heat loss by 2 in a lot of these, because it can make a difference over time of how you size your heater, what you decide on, and a lot of times you can decide on a smaller heater. As long as you're overcoming your losses at the maintain temp, that's all you're trying to do. You're already at temperature. But if everything above that is the input to get it to temperature, and that's what you have to consider. And that's based over time. Hope that makes sense to everyone. That's kind of a wordy way of explaining it, I should say. But okay, so let's move on to the calculators. I use this all the time. I hope everyone has it on their computer. It's, ChromaCalc. It was done years and years ago. We have the, free version and abridged version available to just put on your desktop. Now, is it detailed? Is it, maybe the most elaborate way of calculating heat loss? No, but it is a great estimator, and it's great for budgeting. And I hope you all, when you're talking to a customer, you can calculate very, very quickly what a customer needs just using this. It's that same equation that I just reviewed, done in just a nice, you can do tank heating, and do batch heating would be if I'm going to heat a product up, right? So you can pick the different products, and not all products are here, but you pick something with similar properties. And then you start with that. You got your, your quantity, whatever you want, pounds, gallons, whatever you feel like, whatever the measurement is you're given. You've got your time to heat it, which goes back to that whole correlation of time. You put a safety factor in there. And look, you get it without refining your application, on a high level, look, I know it's about a 200 kW to do that in an hour. Oh, Mr. Customer, you've got 4 hours to do it in. Great. Well, it's, only 50 kW. And that's all fine and good, but this is a quick way, if you're on the phone with a customer, not to take the information, hang up, and then have to call them back and try to contact them. You've got their attention. They've contacted you. Use this to get a sanity check of what the application is. Maybe you're calculating this out and you're going through the parameters of the customer, and you're like, oh, I don't have that much power available. Well, then you need to start the discussion, a different way. Well, how can we make this work, or can you get a power? It helps your credibility. It helps you work with the customer to get to what they need. Now, in the tank heating scenario, what I really like about the tank heater, one, general dimensions, right? Nothing elaborate, but you pick the dimensions. There is a heat loss calculation for support legs and ladders and manways. And you have your maintenance temperature, your startup temperature. You got your outside ambient temperature. All that's good. You put insulation in here. What I really like about this is when let's say you're in the front end of a project and the customer's trying to decide, do they want to insulate? How do they want to insulate? This graph is great. You just cut and send it, say, look, at 2 inches of fiberglass insulation, you're at this loss, you're at this loss. And it gives them a general order of magnitude. Just great to have. It's good for budgeting. I don't want to spend a whole lot of time on it, but if you don't have it, download it. It'll be provided at the end of the presentation anyway, but just be sure to use it. Excuse me. And again, for uninsulated tanks, it doesn't calculate for that. That you use this factor that we talked about from before. Now, if you don't have it downloaded on your computer or you're not in the spot, point the customer to the website. It is on our website, same calculator. A little bit different layout, but it's literally the exact same thing right on the website. So I want to point that out, show that to everyone. Now, the one I really want to focus on is, okay, so you go back to that equation, Q total. Well, it's the summation of a couple different aspects. And so this spreadsheet, which everyone should have or will be provided at the end of this, allows you to select and calculate based on your requirements. You put in the tank information, the fluid information. I'm heating this, from 30 to 60, delta T is 30. That's how much thermal input is required to heat the fluid, in this case, water. But you also have to heat the tank. And look how much kW it takes just to heat the tank. It's a lot of metal. The thickness of metal, the summation, back to that mass, the density in the original equation, you got to heat that mass too. And then you have your losses to the environment. And those are all right here, easy, drop down, select what you need. But what's really nice about this is on the second tab, you're able to actually show the calculation. Again, it's the same calculation. You've got mass, specific heat, delta, mass, specific heat, delta, that 3412, there. Also, for heat loss, now you know your heat loss calculation. Then you can do it by hour and change the safety factors. And you can actually just show in real time or give options to your customer to better develop their application with them to, more importantly, develop using your heating solution for them. Also, I mentioned before that divided by 2 heat up scenario, it's still there. So that's why I wanted to point it out before to show even the calculators have it in their calculation, so know what's going on because it will affect the output of your selection. And ultimately, in this case, to heat the fluid is 730 kW, but in the end, based on the time required and the heat loss, we only need about a 40 kW heater. That seems reasonable. So it's just a good way to illustrate and walk through with a customer on how you get to your answer, how you're providing them the solution. And that, again, at the end of all of this, it will be provided. I don't want to skip around too much on everyone, but it is very much a part of this presentation. Obviously, your inputs, just like we had before, calculate out. But what's great is you get a print sheet on the second page. And that's where you can sit down, you can show the customer. More importantly, it's a check for yourself. One, AE can help you with this, but two, as you're developing it with your customer can look at that and say, oh, you know what, your specific heat's not correct. Or I don't understand why this is doing that. And here you can actually say, I mean, it's a simple spreadsheet, yes, but it's the equations worked out for you. It's just simple, basic, and it's really nice to review with your customer, know it's available. Shoot, let them have it if you want. That will be provided to help with your to help with you and your customers. And let me skip on to the next thing here. So, I don't know, any questions on that? You want to see a demo on that? I got a lot of other things to show you. I just don't want to skip over it. All right, well, I'm going to keep with the same theme of the calculation doesn't change. It's even available in ChromaCal or ChromaTrace. If you have ChromaTrace on your computer, you can go to tank heating and do the exact same thing. Now, it has a few options that are different that are kind of helpful. Obviously, you can name the tank, vertical, horizontal, just like the ChromaCal CAD. You know, miscellaneous would be just labeling different tanks. Dimensions, insulation, we had that. Heat sinks, though. Now, this is nice because you can do a slab. A slab is a giant heat sink at the bottom of the tank. Talk about heating the tank wall. You've got to heat the slab. And you got to do a calculation for that. You got to put some kind of thermal input or consideration into that, or you're going to undersize your heater. You're going to undersize the application. So be cautious. Maybe it's support legs. Maybe it's wind. That can be added in as well. Think of environment. You can put environment in here. Wind speed. Now, it's, you know, not to oversimplify it, it's a simple factor that gets thrown in based on your wind speed, but it's still accounting for it at some level. And that's important to know. Area classification, that's probably selecting, I mean, that'll more or less involve the type of product you want. And this is obviously heat trace, but this can be used for just tank heating, heat loss, and you can use it as a calculator if you don't want to use ChromaCal or if you don't want to use the spreadsheet or whatever. It's still the same equation. I'm going to skip out of that real quick. But I wanted everyone to know that that's very much a part of that. There you go. In here, tanks have data sheets. Customers have data sheets. Customers pay the tank provider or the engineer to create a specific data sheet. That information is there. And it's going to talk about fill rates, volumes, what type of tank, what is in the tank, thickness of the tank. Is there a ground pad? Is there support legs? Everything I just mentioned. And it seems like a lot, but it's really not. It's covered right here on the left and on the heated media. It's covered on the data sheets from way back in the day. You just follow them through. What's the application? What's my temperature? What am I doing here? And so then it goes into real life applications, and that's where it becomes important to review your options, because ultimately, when in a competitive situation or simply just providing the best option to your customer, it's best to understand what they're doing and give them what the options available so they can decide the best option for them. Look, when you're heating externally, you're heating internally, what type of tank, especially bolted tanks. We get a lot of requests for bolted tanks more and more every year. Be careful with these, because bolted tanks most of the time are metal, are mostly carbon steel, because it's less expensive and has a high tensile strength. But after they bolt them together, the data sheet's going to say bolted steel tank. They're going to line it with something. So they're going to line it because it's a chloride's in the water, or it's a special chemical, and it may not be well defined. When you get a bolted tank, like you see down here in the bottom left, ask. Is it lined? What's it lined with? One step further is we're getting polymer and fiberglass requests daily now. And, years ago, we didn't want to put electric heater in there. But we do it a lot now. There's just a couple things to consider. And actually, one came up from last week's presentation, and thank you to Scott Grogan for mentioning this. A lot of a lot of salespeople have started commonly just offering a 1-inch diameter smaller bundle diameter, so it fits into the tank. The problem with fiberglass tanks and polymer tanks is They'll be rated physically for ANSI sizing or Schedule 40 piping or, metal spec. They're physically the same size or bolt pattern, but they're always a little bit out of spec. So the nozzle itself's a little tighter. The bolt pattern's right, but the flange itself is a little off, thicker. So there's a lot of considerations to have that way. Just know if it's a polymer or an FRP tank, we absolutely can heat it. However, we need to talk about it a little bit more in detail so we get you the right product. We don't want to put a heater inside the nozzle part of it, and it's got an extrusion that's 2 feet, and that's the heater itself is only 2 feet. There's a problem. So there's certain things to consider, and back to just simply asking, what are we doing? Well, we're heating a tank. Well, that's easy. In this case, we're heating water, but it could be gasoline, xylene, anything. And then you've got to make considerations for that. So, what do we need to do with that product? So back to the input temperatures. We're heating it from what to what? That's going to give you a starting point, a line in the sand, and then, time has a factor in it. Heat loss has a factor in it. Insulation has a factor in that, and that goes through the materials. A polymer tank is actually, a polymer is an insulator. It doesn't have the heat loss that a metal tank would have. And that's the thing to consider. I always recommend to my customers they insulate their tank, and I am very clear about we don't sell insulation. I can advise you on it, but we don't do insulation. It's going to mean my heater's smaller, but it might be a heater you want to buy. It might talk yourself into a situation. So just always be very open and clear with them. And then how do you apply the heat? We'll get requests all the time of, I've only got a 2-inch opening. Oh, that's great. You need 100 kW to do what you want to do. There's no way to do that. So, the connection size and how to put the heater into the tank, this is where maybe an over-the-side heater becomes an option, or an external heater, like a circulation heater, comes into play. And just, different things to consider. Oh, also, filling rates. The notes say a lot over on the left. Like they'll get you every time. So, make sure you understand the application so you can help the customer understand what they need for their application. And in doing so, watt density becomes a huge part of that conversation. Watt density, for anyone who doesn't know on the call, it's obviously the output rating of the heater based over the surface area of the element. Well, that's easy. And we calculate, everything we have in there is, watt density, the output, and it's basically just the intensity of the element. If you're dealing in mechanical terms, if you're talking to an ME or just somebody who traditionally thinks on the mechanical level, think heat flux. Then they'll be like, oh, I know what you're talking about. That is our way of, our watt density is our heat flux, and that's how they'll correlate those together. Now, our catalog has a lot of recommendations and suggestions. These are general rules of thumb. They don't have to be followed exactly. This is if somebody grabs something out of the catalog and tries to match it up. This is a starting point. It's not necessarily what you're going to end with or what is recommended for the application. It's important to remember, depending on what temperatures you are heating to, heat is a catalyst for corrosion. The concentrations of different acids, chemicals can have a corrosive aspect on it. They could require different watt densities or materials. So even though we have recommendations in the catalog, they're not hard and fast. I can tell you for a fact, for water or steam, some of our boilers run at 144 watts per square inch. In the case of oil applications, if you're only trying to maintain 100 degrees or some kind of viscosity thing, you can bump up the watt density and have a lot smaller heater. Competitively, that can be to your advantage because a competitor could be offering something a lot smaller. Our heaters are actually not priced on their output or their watt density. They're priced more on their physical size. That's where the cost falls into play. A 5 kW heater that's 5 feet long and a 50 kW heater that's 5 feet long, there's not a whole lot difference in the bottom cost. Their list price is going to be marginal if you go through just any of our pricing scales. So you want to be cautious to make sure you get the right product to match the application. The inverse of that, however, is a lot of our competitors, one, don't make their own elements, or if they do, they don't offer the variety of watt densities. They don't manufacture these from the winding to the filling to actually making the elements, and they're stuck to the convention of a lot of 12, 15 watts, 30 watts, and 45 watts. A lot of times they can't offer 50, 60, 70 watts or 25 watts a square inch. And this is where it becomes a competitive advantage for you to find that sweet spot, find where it works. You know, we have a couple people have come recently with a competitor who had distributed watt density. We don't advertise it because we've always had it. We can stretch a coil in a certain part of the element and make, you know, the beginning of the element 30 watts a square inch where the ending of the element is 5. We already have that available. And actually, I think they're probably going to put a marketing piece together on that too. And then the material selection is a big part of your tank heating application. I mentioned before the tank's made out of a certain material, but is it lined? What concentration of fluid is it? Also, it's important to remember our elements are not as thick as the tank. That can have a factor in it. It doesn't take a lot to get through our element wall, which is standard one's 0.028 inches thick. You can get thicker wall tubing, seamless tubing, or you move to the STFX, the LTFX. So we have recommendations in the back of the catalog, and they're obviously rated between, you know, A, B, and C. C depends on condition. B is fair. A is always good. That's good to know. And then a lot of them are blank or say X. You know, what do you do when you come across that, or a fluid, or you're really concerned? Well, we do have the chemical corrosion guides. I'm actually getting it electronic. I'll have it shortly, and I'll post it to the team site and give it out to everyone. But this is great because this measures the corrosion or penetration of the fluid, of the chemical, acid, whatever, based on material and temperature. Back to the temperature can be a catalyst. And this will tell you what temperature you're running. We may be able to even show to a customer, and this example was potassium hydroxide, no, you absolutely can use 316 up until about 300 degrees. No problem. I would recommend that over 304, depending on what temperatures are running. And there's a cost considerations, but having that conversation, showing that to your customer, you know, you're not just selling a widget. You're selling them service. You're selling them a product that works. And that's where you win the value with the customer, where you win the sales side of it. You know, flanges. I bring this up for consideration because we standardize on a certain type flange. Now, ANSI flanges, you know, American National Standards Institute, you know, set size, bolt diameter, thickness, and type. And these are all just, you know, standards that go on the mechanical end, the, you know, tank connection, the nozzle, the flange, and they're all, you know, easy to follow. We offer all. We don't make flanges. We obviously buy, drill, and put our elements in them. But it's also important to remember there's many, many different types of connections to the tank. And this is where you can also help your discussion with the customer. How long's the nozzle? I illustrated that last week of you know, where they'd actually burned the nozzle paint right off because all the heat was in the nozzle area. Have that discussion with the customer. Also, you know, challenge them. If there's a competitor, you know, present, or you know that they're talking to someone else, that's where the challenge comes in. Well, you know, where's their cold end? How much heated section do they have? I want to make sure that they're taking, you know, you're advocating for the customer at that point of, you know, what is this other bid you have, and how does that follow through? And you get them thinking of stuff they wouldn't normally think of. You know, you have to worry a lot of times your customer, a heater is a heater. I really don't care what else goes into it. And that's where that little bit of expertise can go a long way with customers. I also want to point out for fiberglass tanks and special considerations, this is where that nozzle becomes really critical. Another thing I had circled here, raised face flange. And you can see down here, raised face flange right here. There's a blind raised face. There's a slip-on, has a raised face. And what that does, that actually allows for more torque on the bolts. So they'll have a torquing spec for 150 pound, for 300 pound, and the material. And that's what they want to torque it down as. That's great. You seat the gasket, you put the proper pressure on it, and that's all fine for metal to metal connection. So your metal flange to your metal tank. When you're dealing with fiberglass tanks, you've got to be really, really cautious, because if you use our configurator, if you buy something out of our catalog, it's going to have a raised face flange. If you go mating it up to a fiberglass tank, you could cause problems. You can cause leaking. You can cause a gasket not to seat properly. Pressure over time could crack their flange. And then they look down and say, oh, it was the heater's fault, or the salesman that sold it to me, or saleswoman. In that case, you want to be really, really cautious. And that's the expertise where we can win a customer and really do well, but we want to make sure that we're knowledgeable of that and know to ask. That's all. No, I just wanted to point that out because that's been some things that's come up over time. Again, pressure ratings and temperatures, that's all, national standards, ASME, ANSI flanges, all that stuff. The reference guides are in the catalog. If you want something over 600 pounds, we have it. You can find it on the internet. Just talk to your RTSM. They'll help you out with that, or me. And I won't need to spend too much more time on that. Let's talk about budgeting. I'm going to focus on immersion heaters now. As a quick reference, so you got your data sheet. You've got, we'll start with basic flange heaters in the catalog. They break down nicely. They also price that way too. You may or may not realize that. So if you take, we call them base TCNs or base price, find something similar to what you want. And I mentioned before that the cost and price is really correlated to the physical size of it. You may see the one I selected is only 33-inch immersion length and 6 kW. You could bump up the watt density. In the case of this one, it's 23 watts a square, so let's double that. Let's make it a 12 kW heater. You got a 6 kW, 12 kW heater. Physically, they can be the same. And it's good to be conscious of that, because the customer would look at it and say, well, a 6, I should pay much more for a 12. Well, not always. And if the application's water or another fluid that can transfer heat quite well, we can bump up the watt density and keep the same physical size. And we already have a price for that physical size. It's $2,100. We've got a starting point. Real easy to do. And it's in the price guide. Chromalox sends out their price guides now. You don't get a print one, but they're easy to search. You can still find it on the web. I would just use our website, right? But what's in that printed guide, and it gets updated every year. I just want everyone to be aware and that it's there, and maybe it's just because I came from AE and I used to use this all the time. There's pricing for all the standard options. Do I want a thermostat? Do I want a thermocouple? ASME design? I get that question probably every 2 weeks still. There's a standard price to throw that in there. Now, I get in a competitive situation, you want to, it's not just list discount, but it's a starting point. It's a way for you to gauge with your customer. When you come to them and say, well, it's $2,100. Oh, you want ASME? It's going to be, $27. Find out where their break point is to better not leave money on the table, still service your customer, and have the same conversation. You should be able to get 80 to 90% there on price and design with a customer on the phone or in front of them first visit. That's walking through the application with them, getting a better idea. And what happens is you get them thinking about their application and how your product is going to fit into what's going on. Your odds of getting the order have just increased significantly. Now, you may get price shoppers or bargain shoppers, as Adam had them on Friday on the presentation. That's true, but it helps you flush it out too. It helps you know if I need to modify my design to a screw plug or something smaller, something larger. What is going to work for the application? So know that that's there. Know that that's an option. And if you get 80, 90% there, that's going to help you fill out what you need pricing on, and then you go send it to AE for them to either competitively price it, confirm your numbers and design. And if you have any questions about how to do that or input into that, please go to the Dropbox. There's a YouTube of it now too that walks right through our equote system. Quick, easy. You poured it in. It's basically your data sheet. So that's nice and simple and available for everyone. Any questions on that? We can do other examples. Moving on. We also have the configurator. Now, a couple interesting things about the configurator I do want to point out. I'm going to show you just the standard large flange screw plug control panel. Everyone should be familiar with the configurator or had logged on to it. If you haven't, I'll help you get access to it. Just contact me. We'll get you with Dave Weary's, and we'll get that taken care of. But this is on our extranet. These are designing it yourself. You have all the options of the catalog page, but now you can get a little bit more special with your design and even get a part number. Now, what I would each configurator is slightly different, and that can get confusing. And those are some of the things that I want to point out. Now, the easiest one, just starting with flange cheaters, and I'm just going to bounce between the two really quick. I want to point out, so if you can see my bottom left, I've got Internet Explorer. It's very important to know our configurator, because of the programming or the platform that's on, works best with Internet Explorer. I can't even get it to work on Chrome for myself. So if you're having trouble with the configurator and you have issues, start there. You open it in Explorer. Those of you who don't know where it is, it's under Resources. I'll get it to work. There we go. And Configurator. There you go. Pops up. You log in. And then you're off and running. In the case of large tank flange cheaters, now this is a perception thing. We consider large flange cheaters anything 3-inch ANSI flange or larger. So, you know, it may seem like a small heater to you, but please note it starts at 3-inch. And, you know, as it loads up, the thing you're going to notice with the configurator, and as you go through configuring products in our configurator, is each one has a little bit of a different connotation. What I mean by that is, so you put your initials in. In the case of large flange cheaters, the kilowatts are in kilowatts. So if you need 1,000 watts, it's 1 kilowatt. If you need 10,000 watts, it's 10 kilowatts. If you need, you know, 10,500, it's 10.5. It's not the total number. That changes when you go to, say, the LTFX configurator. And then you can, you know, from there, it's pretty self-explanatory. Back to the same questions that are on that check sheet. That's basically how you're filling it out. One other thing I wanted to point out, you'll see selection, especially on three-phase, of three-phase Y or delta. Back to the raised face flange being the standard on anything that comes with Chromalox, so is delta. And the reason for delta, and if you want to get into detail on that, you're welcome to, but go back and take my technical basics. Delta has the least impact if you lose an element to output. And delta is Chromalox standard wiring parameter. So you'll have, if you have 3 elements, they're 3 elements delta. If you have 6 elements, it's still wired in delta, and 2 elements are parallel to each other. So it's just one of the standards that you need to know is there. And that question does come up from time to time. Then you have flange size. That's easy. I mentioned before, 3 inches is the starting size. You only go up to 300 pound. The reason for that is if you're getting larger pressure ratings, you're going to need more, we'll want more eyes on it as far as Chromalox goes. So that's where you want to engage AE. You want to get a better idea. There's still a price adder in the price guide. You can price larger flange heaters. You can price more elements in a heater. This is the basic design they want you to follow until you get into a specialized application. So back to knowing your resources, you also have to know the limitations of what you can configure and what you can't. This doesn't mean we can't offer a 3-inch flange with 6 elements. We can. We can offer a 5-inch element, a 5-inch flange with not 9 elements. We can offer them with 15. But that's where you want to go to AE to make sure you get someone else looking at it that knows how to design those properly and put them in, you know, pricing structure and development. But don't think that that's the limitation. Just think of it as a starting point. You know, from there you've got your element material, and that's based on, you know, corrosion guides, and if it's straightforward, that's easy. Now this is where it gets a little interesting. So you've got standard cold ends that you put on things, and the standard is 4 and 6 inches. That's not that long. If you got a regular 10-foot, 20-foot bolted tank, I bet the nozzle, I'll put money the nozzle is going to be 15, 24 inches extended off the tank. You really don't want to put the heated section in there. So again, these are the standard. You can put longer cold ends. You can put 24-inch cold ends. It will accept that. Now, between the immersion length and the watt density, that will be calculated, and they play off each other. If I put it in a length, let's say just 48 inches, it'll give me a watt density. Or if I change the watt density, it'll change the immersion length. So I don't want to go too far down the rabbit hole, but I wanted to point out a couple interesting things about that. Now from there, it's simple. It's sensors, type K, type J, if you want a thermostat, put the type of housing in there. I think we all know what standoffs, so get the terminal housing away from the flange itself. You can put spacers and baffles. And then summary. Everything requires design approval. I didn't select these because I want to move on to the next thing, but what I want to show you is the specifics. Now, I don't want to bounce back and forth too much. So that'd be kind of a large flange. Now, the LTFX, however, is wattage, not kW. So you have to be careful. So when you go to type it in there, it's 1,500 watts, not 15 kW. And it's the only reason I point it out. It even says just wattage, right, not kW. But I just want to point it out because if you don't point it out, you'll get into a circle of what did I just do there, and that's just something to remember. Everything else is pretty much online. You got the watt density, same thing over again. One thing with the LTFX, though, to get a hazardous rated LTFX, that's class 1 div 2, I know hazard is relative, you have to be 4-inch flange or larger, or it doesn't fit. And that's just because there's not enough space on the flange. So you may get in there and decide, why can't I get a 3-inch flange with an E2 housing? Because you can't. It doesn't fit, and it actually will not let you configure one. Flipping back to the watts, not kW, the same with screw plugs. They're in watts. Also, you get screw plugs, very small screw plugs that are 200 watts and all that, which is really good. And it's basically the same selections over again, just like the flange heater. I don't want to bore everyone on the call with that, but I wanted to show you that it's there. Now, this one is unique, I have to say. The STFX specifically does not give you a lot of options, and there's a reason for that. It aligns specifically with the catalog. And what I mean by that, and I'll just skip over there really quick. If you go to the STFX configurator, so where the LTFX is, pretty much configure it however you want, the flange heater, the screw plug heater, all the same. The STFX, however, is modeled right after the catalog pages, so the selection breakdown. And what I mean by that is if you start configuring an STFX that's larger than, say, 25 kW, it will convert back on you. It won't let you. So if I go to, I'll put in 50 kW, right? You see how I just jumped back to 25? It will not let you go over that. It will not let you deviate from a catalog item. And it's important to know that because I know several people have fallen into it. I've fallen into it myself where I go configure something, I think I've done it right, and I know what I want, and then it's converted back to a catalog item, and I don't even pick up on it. So now here I am offering something that I didn't even want. So you have to be a little cautious. It'll give you the same pricing, the same part numbers, and all that from the catalog, but know that the STFX specifically, you're selecting what's in the catalog. It will, and I will show everyone the call that again. Even if you go to 40 kW, it's going to go back to what's available. Same with lengths. The idea is not to give. You can get different options, but the idea is not to immediately offer different options. The idea is to try to fit it into what will work. And that's not a bad thing. That actually kind of goes true with our pick and ship program that's coming up, and I'm going to show you a little bit of that, hopefully within the hour. But moving forward, the contactor is, the control panel, contactor, SDR selection is exactly the same, straight from the catalog. You can price and design as that. And quite honestly, just go through the walkthroughs. They're 10 minutes long at most. We've done, there's not only these, but there's also flexible heaters and a couple others that we've done. They're available. The links there, you're welcome to them. They're also on YouTube. I've said it before. If you have questions or you just want a quick refresher, make sure you're using all the right capabilities of the configurators that are available. So I wanted to point that out. A little bit back to design, when you are talking to a customer and you're back to that data sheet, something that doesn't always get illustrated on there, you might have a lot of connections and ports that are noted on there, but they don't really say what to or what's in the tank. A lot of times tanks have agitation, level control, pressure relief valves. You need to take those into account. And simply bringing them up and having the discussion with the customer will let them know you know what you're talking about. You want to walk through that with them. One step further is the, back to the control panel. When you're configuring control panel, those are just customer connections. Most of our controllers, even the standard ones in the catalog, you'll see the selection for the, the controller 1 and the overtemp controller. Those other signals can be configured specifically for level control, shutoffs, so emergency shutoff. So just know that they're there. They're easy to find, and we got a controls presentation in 2 months with James Lewis, where we're going to walk through those in detail. But specific to tank heating, they could either be an obstruction that you're trying to design around, or something that they want to include in the control of the heater. We always say we don't want the heaters to be exposed or be open to air or the level go below the heater. There's level control right there, right? So just an important thing to point out. And then environment. Is it by the ocean? Is it up in a mountain somewhere in the cold? Is it buried in snow? Easy things to discuss, but need to be part of the conversation, because on a data sheet says one thing. Reality is something else. Data sheet could not mention that it's sitting next to a port where salt water is hitting it all day. Well, guess what? I'm not going with stainless anymore. If it's going to be buried in snow 4 months out of the year, 6 months out of the year, that's something to consider. I don't even care if it has insulation. When it has 6 feet of snow buried under it, that's going to be a factor. And then area classification. And what I would like to bring up about area classification specifically is the control panel versus the heater. We can mount the control panel to the heater. We talked about that. But a lot of times, especially in Class 1 Div 2, Class 1 Div 1, hazardous area, we'll just define it as that, area classifications. A lot of times, if you just move 5, 10 feet, sometimes just on the other side of the containment wall, that area classification changes. You're at a safe distance. Your control panel no longer has to match the terminal housing of the heater. You can get away with a NEMA 4 or NEMA 12, NEMA 1 or NEMA 12 control panel outside of that area. And that's a design advantage. Don't walk into just bring it up to them, saves them money. And a lot of times they may not even consider that, and they may walk you down the wrong path. So definitely something to remember. So all of this is the idea of developing your credibility and how you can help walk them through their application to provide them the right product, obviously with the underlining thought of you're going to buy my product, of course. But that's by providing value and extra service. That's how you're going to get there. Now, I didn't leave a lot of time, but I do want to touch on one last thing before we go is the pick and ship, and we're getting there. So as a summation of the tank heating presentation, the questions asked and the things to do, this has come up time and time again. We have simple spreadsheets of these exact questions. Either know them verbatim, take the sheet with you, send them to your customer, walk them through there. It will actually, it will funnel you to the right solution for your customer. It will funnel you to the right solution, period, for what you're going to offer the customer. So it helps you as much as it helps them. And those sheets are provided with the presentation as well. So to speed it up here before we get done, the pick and ship. Hopefully all of you have seen this. You've heard about it. Mark Wheeler did a big presentation on it, which was back in December, presentation 25. Essentially, the gist of this, and I will summarize it and update it quickly, was they went through the sales history for Chromalox and decided, what were the core options for, that met 80% of the sales, like what was out there. And the thought was to, first of all, identify what they were, and that was, 480-volt heaters, obviously an overtemp, EMA 4, ankle A elements, 150-pound flange. That all became, 80% of what we sell. So he mentions it as the 2/3, right, or the 80-20 rule. And what they did from there is they developed a short list of part numbers. Now, they matched them to breaker sizes. We can have a discussion about that later. You can call me on that. Yes, it is specifically to that breaker size. I'm sorry, to that amp rating. I won't say breaker size, amp rating. Be a little careful with that. So if your standard breaker is 30 amps, it does not have the NEC code in it. So it's going to, that 24.9 kW is specifically 330 amps. So you're going to have to probably size it a little bit better. So kind of keep that in the back of your head of how to size those around. But more importantly, the watt densities and the selection around that is they developed a matrix of stock items. These are on the shelf. These are available. So when you have the conversation with your customer and when you get to the point of you need a 15 or 20 or 30 kW heater, do the application, and then you hit them with it's 2 to 3 weeks for approval drawings and another, 4 to 6 for delivery, and they're like, I need it next week. Guess what? You've already identified what type of customer you're working with. You have an option to provide them. You can say, look, we can get you 2 of these or 1 of these, and we have these on the shelf. How would that be? Can we make this work? And then they're not maybe searching around for another product. Now you're saying, look, it's an either-or scenario. We can build you one specific, or we can match one of these up. Back to the caveat, heat's heat. I mean, you're providing them heat. Is it going to do the trick? Sure. As long as we take into consideration the material, the watt density, you have that option. You can design that up. Pick it and offer it. I would bring this up to them anyway when designing your other stuff, just to let them know that option's available, so they don't maybe see your lead time and run off and look somewhere else. It's like, no, we have the whole gamut covered. I would like to sell you something today if one of these works, and know that it's out there. It's only a few part numbers, I think 17 total. And then this one's really key. I really like this, and this is something I've done for years. It's the ancillary products. It's the thermal well with the thermocouple with the housing and the extension wire. Now it's done for 50 feet and 200 feet distances. One part number, you get all those components all in one. The sheet's right there. The part numbers are right there. So, I kind of just mentioned the best way to utilize it. It's the key components that I just talked about. If it meets this criteria, if you keep this one page, or just show them this page. Hey, look, if we can fit it into any of this, we have one on the shelf. We can give it to you, tomorrow if you need it. So I think that's a really good. We've got our other sales options, we've got our other design criteria and all that to offer, but this really gives us that other side of things. Oh, you need something right out of the catalog that meets? Boom, there we go. And I think that's really a good way that we're evolving as Chromalox to offer more things to customers, and they're developing it to other products. We're going to have a control panel one, I think, released in May. I'm not sure. I haven't heard an update on the circulation of duct heaters. I have a feeling they might be pushed off till the summer. I think they're redirecting the duct heaters. But the panels themselves was originally scheduled for the 19th, is now going to be scheduled for the 26th. You'll get that in the update next month. Are there any questions before I summarize this up and complete? All right, well, as we finish up here, this presentation, along with the one before, will be posted and available There'll be an exam that comes out with it, just a couple quick questions that focus on the key points. Please take that so you get credit for taking the course. Provide any feedback to me. Any feedback's only going to make it better. A couple other things I want to point out is, a couple presentations that are referenced in here that are also available. There are YouTube's linked to them as well. The e-quote process, if you have any questions about going through that. Working with Chromalox, the pick and ship, more importantly, the configurator walkthroughs are available. All who participated today will get an email here shortly that'll have all this information, all these calculators and all that stuff. There'll be a short exam. Please take the exam, provide some feedback, get credit for taking the course. And I thank you all for joining me. Coming up, this was tank heater. Next month, we're going to have heat transfer and boiler systems. We're going to have, I know Mark's going to help us out a little bit with that. Some new products to offer there. Control panel designs, we're really going to dive into that and take it a little further than we did last year. And James Lewis is going to be helping me with that. So I'm really excited about that one. And then some of the sales strategy that we're working on. Don't forget to sign up for the selling process, which is going to be a 3-part presentation. So we're going to have budgeting for me, but we're also going to have value-added selling components from Jim Summers. We're going to have a PPE and FRP presentation later on that month. The pick and ship panels has been moved to the 26th because none of us realized that was Good Friday. And if you missed the price increase negotiation presentation from Adam Hilligenstein, the links there will be provided with the email as well. And with that, I will stop the recorder anyway.